Alright, today's lesson we're looking at hominin evolution. Okay, so far we have looked at the classification of our species, starting from all the way from let's see, domain to kingdom, eminence. Or I'm not gonna go so far. Just go from part 31. So basically, we were looking at previously, we looked at mammals, and then we looked at primates. Then what's after primates? Sorry? Hominoid. Hominoids. And then lastly, hominin. Yeah. So hopefully you guys remember what are the defining characteristics for each of them and how we are getting more and more specific towards the hominin evolution. So once we get to hominin evolution, we will talk about how the trends of evolution eventually led to the emergence of Homo sapiens. But also the fact is that it branched out to give a lot of different variation. So just like how we've talked about evolution giving different branches based on different uh, environmental pressures, the same thing happened with hominins as well, where different species emerged depending on different needs and different environmental pressures. So we're going to try to look at it and try to have a understanding of how eventually it shaped into the emergence of Homo sapiens as well. Right? Right. First question. Which of the following characteristics are shared by both hominoids and also hominins? What's up? The answer say. All right. So essentially, things we have in common with hominoids and also hominins. Let's look at the defining key defining traits of a hominoid. What were they? Look at Tavis. Hominoids, what were the key characteristics that we talked about in the last lesson? Sorry? Larger brain size, that's one. Color vision. Sorry? Can't hear you. Lack of tail. Yeah. And then when we get into hominins, we start to get stuff like bipedalism and also larger brain size as well, and so on. So everything you see in A kind of fits that tone as well. All right, so today's lesson, we're gonna identify and compare the following changes in the brain size, limb structure between hominins that emerged, right? We have a bunch of hominins that emerged with three different genuses in particular. Two are going to be stressed. One is the Australopithecus genus and also the Homo genus, right? What's important for you to know is to be able to evidence how the trends happen, basically how the changes in these kind of structures happen to show basically a timeline of how the hominin tree evolved over time and how eventually that gave rise to modern humans as we know as well. Right? There's only three words that you need to know. So meet the hominins, right? Basically, hominins are a family that diverge from a common ancestor with bonobos and chimpanzees, right? So at this point, we have the hominins diverging from the chimps and bonobos and becoming a family on their own. And in this family, we have a lot of different emergence of species, and only at the very end did Homo sapiens evolve, right? So this family line has been happening for many millions of years, and humans, Homo sapiens, only emerged about 200,000 years ago. So we need to try to understand how the changes occurred in the the hominin family, such that we eventually gave rise to modern humans as well. So also another note is that in the family of hominins, there is only one remaining tribe. In the tribe of hominins, there's only one remaining species left, which is Homo sapiens. All other species are no longer existing. I think you would have noticed if they did. Uh, some of the defining characteristics of this tribe is that they have bipedalism. Basically, they were starting to walk with both legs and being able to walk around like that. Their spines were more S-shaped, and also their pelvises were becoming more bowl-shaped as well. We're going to look at that key defining traits throughout the lesson. Okay, so looking at the tribe of hominin, you can see that there's a bunch of different species that fell under it, and they all emerged at different timelines. Some were overlapping with different species as well, while some were the only tribe to exist, only species to exist in the tribe during that time period. For example, if you look at Homo erectus, there is a point where no other Homo genus was present other than Homo erectus. So they will basically ask you questions about these kind of trends. So it is important for you to be able to look at this trend and try to understand when and how they emerged as well. Right? So essentially, if you can remember this table, you'll pretty much be able to do fine. You don't have to remember the specific names of all the species, but you have to try to remember which one is the oldest, which one is the youngest, and such, to show a kind of a trend of how they moved along, right? So the main focus would probably fall towards Australopithecus and the Homo genus. You don't really have to remember all the top ones, but make sure you focus on remembering the genus of Homo and Australopithecus. Remember which ones were the most significant one. Remember that Homo erectus existed appeared about 1.8 million years ago, lived until little as 200 to 300 years ago, and they were basically much more human-like compared to anything prior, and they were starting to have the traits that are indicative of the genus Homo, which are bigger brains, longer legs, shorter arms, and more sophisticated tools. And they are basically credited towards migrating out of Africa. So we will look at the migration patterns in another day as well. But essentially, try to remember the Australopithecus genus and also the Homo genus. So some of the general trends we can observe through the evolution of hominins is the basic ones that we've looked at as well so far. One is obviously the brain size increase. That is one thing you can always see happening in the evolution of hominins. Basically, evolution gave survival advantage to those that evolved a bigger brain size. And we're going to look at how that is the case in a bit as well. And to support that increase in brain size, skulls also became more rounded and smaller, right? Meaning that their faces gradually became flatter, and also a lot of features changed as well. So basically, if you look at this skull, this is a Australopithecus genus skull compared to a more modern Homo sapiens skull. And you can see there are very prominent changes that have happened throughout the evolution. For one thing, we're going to look at, for the most obvious one, is the fact that the brow ridge has become much flatter, the teeth are more different, the face itself is flatter rather than being in a slanting position, and also the cranium, the shape of it is much rounder, and so on. Okay, we're going to look at all of those changes that occurred. Another thing that occurred is also the fact that the early Australopithecus genus was still arboreal. What does that mean? Is that they were still living around or on trees, right? They didn't completely evolve to have bipedalism yet, and they were still living on trees or around trees, while also still having the ability to be able to be bipedal, right? Meaning that they could walk around on two legs, but they also still live in or around trees. Whereas more modern, the genus Homo became more and more uh, lean towards more and more complete bipedalism, where they were basically always walking around with their two legs and also no longer living around or in trees. Okay. As a result, we also have changes towards their arm length and also their leg length, right? Their legs became longer compared to the Australopithecus, while also getting shorter hands because they weren't relying on the trees anymore. They didn't need to swing from trees, they didn't need to hang from trees. So their arms started to shorten out, and also their legs started to grow out more to support their complete transition to complete bipedalism. Another thing that also changed as a result was their shape of their pelvis to also support that transition into complete bipedalism, right? So we're looking at this specifically, looking at coming from looking sorry we're looking at this specifically coming from Australopithecus all the way to modern humans, and as such we are going to look at one specific trend of changes rather than how the entire genus changed. So make sure you are aware of this. We're looking at it coming to Homo sapiens, so we're looking at one specific trend. That's why you're going to see all these trends happening. Okay, so the first thing is that from Australopithecus coming to modern humans, we had a increase in the brain size, almost a threefold increase in brain size compared to the early Australopithecus, and this basically had its advantages and also disadvantages. First disadvantage obviously is that it comes at a nutritional cost. Our brains are very, very hungry. So basically, our human brains only take up 2% of our mass, but they take about 20% of our nutrients. So every day, 20% of whatever you eat is actually being used up by your brain itself, even though it only accounts for 2% of your mass. Another disadvantage of increasing brain size is that it also presented a higher complexity during childbirth. Because think about it, bigger cranium, bigger brain size means that it has to be able to go through the birth canal, and sometimes, when it is increasing in size, it also increases the complexity at childbirth because passing through the birth canal with a bigger cranium can increase the complexity. Another one is also it required a larger diet. Basically, that comes underneath higher energy needs. So these are all the negatives of having a larger brain. But there are also uh, positives, basically a lot of advantages that drove us to have bigger brains. One is obviously a higher cognitive process, being able to think better, plan better, be able to have speech and abstract thinking. These were useful traits that provided a lot of benefits. Also, we also became better at social outcomes related to child rearing and also hunting. So we started to be able to share our practices and cultures among other members of our tribe as a result of being able to have a more complex and bigger brain. We also be able to, as a result, come up with tool production as well, and that only became more and more complex over time due to another benefit of the social outcomes, which is the sharing of cultures and practices. So that one idea, sharing of culture and practices, was instrumental in the development of better outcomes for humans, specifically in the sense that, think of it like this, over time, we were able to share knowledge of how to do things better to every generation that emerged, right? We can tell them, this is how you hunt this animal, this is how you avoid this predator. Share the knowledge every generation, and that is only possible due to the fact that our social outcomes improve as a result of a bigger brain. So early hominins were able to transmit their knowledge and cultures and their skills to their offspring because of this better social outcome. So this allowed for the evolution of collective knowledge that they held in the sense of language, ideas, beliefs, and customs. So this allowed them to basically undergo a cultural evolution as well, not just a biological evolution. This meant that following every generation, they were more equipped or more knowledgeable about surviving the harsh uh, world that they were living in. And this is something we even continue up till today, right? We share our knowledge to each generation such that they are better equipped to face the challenges that come today. And you can see what the benefit is here, right? So essentially, tool making started out with something as simple as a stone, right? And if no one passed on the knowledge of how to make it better, or no one passed on the knowledge of tools, then it would have stayed right there. But as a result of hominins being able to share their knowledge, share their culture with each other, at each generation, it became more and more complex towards the task, to the point where we even started to make spears and basically get very good at using them as well. So this is a result of the uh, knowledge sharing that emerged as a result of the bigger brain. So this idea is considered the expensive brain hypothesis, that basically outlines what are the negatives of having evolved a bigger brain and what are the positives. And obviously, there were more positives to having a bigger brain. That's why evolution leaned towards that direction, right? Another thing to note is that uh, we don't actually have a evidence of knowing whether the brains were bigger or smaller, because we don't have fossils of brains. Brains don't fossilize. The only way we are hypothesizing that the brain size increased is due to the fact that the size of their craniums, basically their skulls, increased as well, indicating that their brain size increased as well. So we are basically making a kind of an assumption based on the cranium size rather than actually having actual brains to look at. Okay, so brain size increase, cultural evolution happened as a result, and they were also able to be better equipped to survive in the world. So to support the fact that brain sizes were increasing, their skulls had to undergo a structural change as well, because the Australopithecus skull cannot support a larger cranium. Its shape is not conducive to having a large brain. So the structure in the skull structure also underwent evolutionary changes over time to come in line with the larger brain size. Some of the most obvious one is the first one, a more centralized foramen magnum. Basically, a foramen magnum is basically where your spinal cord enters into your skull. And in the early Australopithecus, it was leaning towards a more, what's what I'm looking for? So more towards the back of the skull, whereas in the hominin skull, it's more centralized at the very center, meaning that it's more centralized towards the spine. Second one is shrinking of the sagittal crest, which you can see as number 2. You can see there's this bump up here. That's the sagittal crest. In Homo sapiens, in the genus Homo, we can see that that was starting to shrink as well. And the more obvious ones were the shrinking of the brow ridge, right? You can see with the Australopithecus skull, there is a very prominent brow ridge that you will see in models of them as well. Whereas in the genus of Homo, you can see that that was starting to shrink away. So legs is the flattening of the face, which you can see compared to the other one. Less prominent chin, less protruding chin. So as you can see that. And number 6, a more domed skull. So the shape of the skull. This one is more, I don't even know how to describe that shape. But with the Homo, the genus Homo, you can see that the skull started to actually become more of a dome shape. And obviously, lastly, smaller teeth, right? These teeth are more in line with a primate's teeth where it's large, while when you can look at the genus of Homo, you can see that their teeth started to actually shrink in size. So out of these changes in the skull structure, you don't really need to know all of them. I would suggest knowing at least 2 or 3, and I would suggest going for the more obvious ones, which are the shrinking of the brow ridge, because that's something you can see happening very obviously. The flattening of the face, and also the changing the shape of the skull itself. So with a genus Homo, the genus of Homo, you can see that their skull started to have a much more clearer dome shape compared to the Australopithecus genus, right? So try to remember at least a few of them as such. So if the first general trend of evolution looking from Australopithecus to the genus Homo was talking about the brain size and how the brain size was accommodated to the transition, the change in the skull structure. The second was the reduction of the arm to leg ratio. So this basically was in response to the genus Homo becoming more and more bipedal, right? Compared to the Australopithecus genus, where they were still being arboreal, meaning that they were still living around trees or in trees. So in the transition of becoming more bipedal, 2 things mainly happened. Sorry, 3 things, but we're looking at 2 first, which is 1, their arm sizes actually started to reduce because we weren't hanging from trees anymore. We weren't needing to swing around from trees. We weren't hanging from trees. We didn't need to use our hands for any tree related purposes. So our arms became more suited towards tasks that required more fine control, where such as building and handling tools, preparing food, and carrying children. So our hands actually became more dexterous to be able to handle these kind of tasks, which you can actually see over time. And our arm sizes also reduced because we did not really need to use them for the task of hanging from trees. But as a result of increased usage of our legs and also needing to be able to support our entire body weight for a much longer time, we also increase our leg size. So that is to better support the transition to complete bipedalism. So longer legs positively affected our stride length and also allowed for more efficient upright walking. So anything that allowed us to better walk uh, using our 2 legs, which is basically increase in the leg size, that happened throughout the evolution of Australopithecus to Homo sapiens, as you can see. So the transition happened throughout the entire evolution of the hominin tribe, where we start off with the Australopithecus genus. They obviously have a short legs, very long arms because they're still living arboreally, meaning that they were still living in or around trees. And throughout the evolution, going into the genus of Homo, you can see that their hands are starting to basically decrease in size compared to their legs, which is increasing in size. That's why they say arm to leg ratio was decreasing, right? And at the very end, we have Homo sapiens. You can see that there's a significant change compared to the Australopithecus, where our legs have increased much more, and our arms have somewhat reduced as well. All right. So there was also one more change that occurred. This was also to support bipedalism as well, where the pelvis shape actually became more of a bowl shape. So this is not really that obvious if you can't see it, where the pelvis of the Australopithecus versus the pelvis of a Homo sapien, what you can do to describe it better is basically the shape itself, right? Let me zoom in. So looking at the Australopithecus pelvis, it's more rounded out. It's kind of bigger as well. Its size is also bigger, right? And it's not really a bowl shape. It's more of a, I wouldn't know how to describe the shape, but basically the transition happened to create a more bowl shape over time, where if you look at a a Homo sapien one compared to the Australopithecus one, is that the size actually reduced and also the shape is much more bowl-like over time. So these are the two ways you can actually describe the change in the pelvis shape, where it actually became shorter and also more bowl shape over time. And this is basically done to provide better support for the upper body whilst standing and walking upright. So the two changes that the two things that it was basically supporting as a result of the change in the pelvis shape is one, it led to more efficient walking, where we were using less energy for longer duration for us to be able to walk. We were able to walk for a longer time while also using less energy. And also, this was also done as a response to the demands of childbirth. So remember how we said that brain size increase meant that there were more complexity in childbirth. So the pelvis shape also started to change better to give a better outcomes when it comes to childbirth, where the cranial capacity of hominin babies needed a more bowl-shaped pelvis to allow for better outcomes for childbirth. Any questions? So remember that this is not as if we are, when we're thinking about these trends in evolution, it's not like it was always heading down this path, right? It's not like this was always going to happen. The way that this chapter is shaped, it always gives people the conception that, oh, Homo sapiens were always going to emerge. It's always was always heading down that path. But remember that this is going to be, you have to look at this under the context of the principles of evolution that we learned as well. Okay, there was variations that existed within a population, and selection pressures basically selected for it. And over time, more different and different species evolve, right? So the selection pressures that existed are the ones that basically selected for different traits, and over time showed we can actually look at how those selection pressures selected for different traits to give a general trend. Okay, selection pressures actually wanted to give way to beings with larger brains, and also basically all the other things that came as a result of it. So for the purpose of your BC biology, it is necessary for you to be familiar with the general trends of hominin evolution, including approximate periods and patterns of development of our taxonomic tribe from earlier Australopithecus to modern Homo sapiens. So the three main changes and overarching trends that you can see over time are the ones that we've looked at, which are larger brain size, which is basically the fact that over time, hominin brains increased in size from Australopithecus all the way to modern Homo sapiens, where there was a threefold increase in brain size. And that meant that there were a lot of other morphological changes that occurred to support that increase. Basically, the changes in the skull structure. Second is the smaller arm to leg ratio, that is to support the transition to more efficient bipedalism. And lastly is the changing of a pelvis shape, which is basically developed in relation to our bipedal lifestyles and also to allow for better outcomes for childbirth, right? So that's why the last one is basically supporting bipedalism and also the fact that the brain size increase.